Quadratic equations and the quadratic formula. I can tell how excited you guys are for this today. Okay, 2 days ago we studied quadratic equations and we solved them by graphing in tables, right? Yesterday we looked at quadratic equations and we solved them by factoring, right? Today and tomorrow we're going to look at solving quadratic equations using the quadratic formula. Okay? Before we can get there though, there's a couple things that I need you to know. First of all, we got to know about imaginary numbers. Okay? There's two ways that we can define the number I. Now, first of all, I know that people have been telling you for years that I is a letter. And the reason they tell you that is because it's true. I is a letter. Okay? But in math class, I is also a number. It represents what? It's the number you can square to get an answer of -1. So if I say I squared, what does that equal? It's the number you can square to get an answer of -1. What does I squared equal? -1. Okay? Another way to say it is I is the square root of -1. I is the square root of -1. Any questions about that? No? When you have a negative number under a radical, you can take the negative out as an I. For example, if I say the square root of -1, no, let's not do that. Let's do the square root of -9. Okay? The square root of -9. Because of properties of square roots, I know that this is the same as this, right? Isn't -9 really the square root, isn't -9 really -1 times 9? Now, do you know the square root of -1? It's I. Do you know the square root of 9? 3i. Done. So what about the square root of -25? That's really the same thing as -1 times 25. What's the square root of -1? I. What's the square root of 25? 5i. What about this one? This one's my very favorite one. Same as the square root of -1 times 16. What's the square root of -1? And the square root of 16? So do you see why this is my favorite one? My nickname from when I was a little kid. 4i. Yeah, it's fine. I'd say I'm over it, but you obviously know I'm not, so it's okay. Okay? Like I Frankenstein. Yeah, okay? So it's probably square root of negative Frankenstein, and so now it's I Frankenstein. Now, always we said, what's the square root of -1? And we said I. And what's the square root of 9? And we said 3. So why didn't I write I3? Because we kind of use the same properties as if I was a variable. It's not. It's a number that represents the square root of -1, but we put it after the number. Traditionally. Okay? You do all this work on a test and you write I3, I'm not counting it wrong. Okay? So let's do some example problems real quick. What about the square root of 49? What's that? 7i. What about the square root of -121? 11i. What about the square root of 64? 8i. What about this one? What is 17 minus 42? Oh, -25. What's the square root of -25? 5i. Good, because we already did that one, right? Good. What about this one? Dun dun dun. Okay, remember what's happening. It's really the square root of -1 times 3. What's the square root of -1? What's the square root of 3? I don't know either. I root 3. Done. Yep. So what about the square root of 7? I root 7, because I don't know the root of 7, do I? Okay. What about this one? Dun dun dun. Come over here. -1 times. Now it could get a little tricky if you let it, but don't let it. Can't I say 12 is 4 times 3? Why did I choose 4 times 3 and not 2 times 6 or something? Do I know the square root of 4? Yes. What's the square root of -1? I. What's the square root of 4? 2. What's the square root of 3? I don't know either. 2i root 3. So what about the square root of 24? Well, that's -1 times what? 6 and 4. So what's the square root of -1? What's the square root of 6? I don't know either. What's the square root of 4? Done. We good with that? Okay. Keep in mind the number inside that we know the square root of, it doesn't come out. This is not a 4. We actually have to take the square root of it to bring it out. Does that make sense? Good. So what about this one? Well, this kind of just stays there, right? Because I don't do anything with that. What's the square root of -25? 5i over 7. Can I do anything else with that? No. Here I'm going to get the square root of 40, right? I've got to take the square root of 40. What is the square root of -40? -1 and 10 and 4, which means it's going to be 2i root 10, right? So I've got 4 plus or minus 2i root 10 over 5. Can I do anything else with that? No? While the numbers in the numerator both have a common factor, do you see that both of these numbers are divisible by 2? The 4 and the 2. I'm not paying attention to the 10. I already simplified the 10 as much as I could. I can't get inside and simplify it anymore, can I? So even though the 10 is also divisible by 2, I wouldn't do anything with it. Just the 4 and the 2. But the denominator is not divisible by 2, so I don't need to worry about it. Ask me. I don't know, because I'm thinking about later. It's just plus. Thank you for asking. I'm just so excited for this lesson. So what about k? 12 plus what? 6i over 2. They're all divisible by 2, right? So I can simplify it one more step. What's it going to be? Six plus 3i? Because remember what happens is I took a 2 out of each term in the numerator, and factors can cancel, can't they? Factors simplify to 1, don't they? And what's left is 6 plus 3i. We okay with that? Okay. I also need to talk to you just a little bit about complex numbers and complex conjugates. Okay? Complex numbers and complex conjugates. A complex number is the sum of a real number and an imaginary number, and it's usually written in the form a plus bi, with the real number part first and the imaginary number part second. Does that make sense? So we're going to write each of these numbers in a plus bi form, and then identify the real part and the imaginary part. Okay? So this first one would be 25 plus 0i. Right? So what's the real part? 25. And what's the imaginary part? 0i. Okay? M. 0 plus 25i. Now, have I changed the value of the number by adding 0? No, but I needed a placeholder for my real part, right? So what's the real part? And what's the imaginary part? 25i. Excellent. What about n? It's already a plus bi form, so I don't need to rewrite anything. What's the real part? And what's the imaginary part? It would be negative 5i. Very good. Very good. Okay? Oh, I got to simplify this, don't I? Okay, so I've got 9 plus 12i divided by 6. What do you notice? They're all divisible by 3, so do it. 3 plus 4i over 2. So what's the real part? 3 over 2. Excellent. What's the imaginary part? 4i over 2. Do you see that? Because everything in the numerator is being divided by 2. Each part, right? Can I rewrite this as something else? What is it? 2i. Any questions? You okay so far? Okay. What about p? Absolutely. You combine like terms. What do you get? Close. Negative 4. Uh-huh. Thank you for trying to do the math in your head. 13i. So what's the real part? Negative 4. What's the imaginary part? Have you guys ever done this before? So you're just really smart. Today. Just teasing. So what about Q? Q is a trick. Just so you know, Q is a trick. Absolutely, you would have to do that. You would have to distribute, right? So 6 times 6 is what? 36. 6 times negative 2i is what? Negative 12i. Okay, so just like with variables, I can't combine like a 3x and a 4 because those are unlike terms. I can't combine like summing or differencing. I can't combine numbers like that, real and imaginary, but can I multiply real and imaginary? Yes, just like you can with variables, right? Okay. Then we have 2i times 6. So plus 12i, and then 2i times negative 2i. Here's the trick. Here's the trick. It's negative 4i squared. But what does I squared equal? Wait, what is, if this is negative 1, what is negative 4 times negative 1? Oh my goodness, so that's really just plus 4. What is negative 12i plus 12i? Oh my goodness, 0i, 0i. And what is 36 and 4? 40. So all that work to get 40? Kidding, right? Not kidding. What's the real part? And what's the imaginary part? 0i. Okay? Here's where the plus or minus comes in. You asked me about it just a second ago. Here's where it kind of starts to creep in. Okay? A conjugate of a complex number has the same real part, but an opposite imaginary part. So if you have 2 plus 3i, then the conjugate is going to be 2 minus 3i. Also, if you start with 2 minus 3i, its conjugate is 2 plus 3i. It's the opposite of the imaginary part. Okay? So if here's the number, what's the conjugate? It's just 25, right? Because it would be 25 plus 0i here and 25 minus 0i here. And since we don't really care about that, we just leave it alone. Okay? What about this part, though? It would be negative 25i. Very good. Okay? What about t? Same real part, opposite imaginary part. So negative 3. minus 6i. Yes? So what about u? 2 plus 3i. Oh my goodness, I don't even know why I drew a t. Let's pretend it's a plus. What about v? Negative 12 plus 5i. Excellent. Ooh, w must be hard. There's fractions in it. 2/3 minus 1/5 I. You guys are geniuses. What about x? Yeah, exactly right. What about y? Okay, and z. Yeah, plus. You got it? And now it's time for my favorite part. Now we've done all that stuff, we can look at this table. We can look at this table in a minute, okay? I want to teach you the quadratic formula. It's at the top of that page, okay? It's at the top of the page. But this is one of the formulas you need to know. And so I'm going to teach it to you in a way that you're going to remember it. The best way that you know of to remember stuff. We are going to sing it. And it goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sing it with me! Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, some of you are too cool to sing this with me, so what I need to let you know is that we're going to sing it until we're all singing it. So let's try a third time. Ready? One. We're singing this right here. The formula, quadratic formula. It's on the top of your paper. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But what's it for? It's not any good to know a very cool song if you don't know what it's for. What can we use the quadratic formula to do? Solve quadratic equations. That's exactly right. Okay? What's up? So, we're going to talk about discriminants here in just a minute. Let's go down here. I just want to solve a problem first, just so you can see how it goes. Okay? So look at problem A. In order to solve it, don't we have to know A, B, and C? In order to plug anything to this equation, we have to know A, B, and C, don't we? Okay? So look at example A. First of all, we have to get it equal to 0. Okay? To get this equal to 0, I'm going to add 2 to both sides. 3x squared plus 7x plus 2 equals 0. So tell me what A is in this problem. A is 3. Remember, it's not the x squared with it, it's just the variable in front of the x squared. Okay? What's B? 7. And what's C? 2. Okay? So here's how it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you. I'll be performing all week. Now, did I actually write 7 squared here? Okay. I go ahead and square that in my head, or even use my calculator to square it right now, because what's going to happen when you square a number? What are you going to get? Won't you always get a positive number? Even if I'm squaring like negative 3, won't I get a positive 9? No matter what I square, it's going to be a positive number. And I can't tell you how many times people mess up right there, because especially when b is a negative number, they just put negative 49. Because what they do in their calculator, is they say, oh, you can't even see that, sorry. They say negative 7 squared. Now, I know it's not negative 7 for this problem. I'm just trying to give you an example. Okay? Look what it tells you. Negative 49. So did the calculator get it wrong? No. You told the calculator to square the 7 and then multiply by a negative. And that's what it did. What you meant was parentheses negative 7 squared. Isn't it? But I can't tell you how many people forget their parentheses. Because what you're telling the calculator to do here is to square a negative 7. What you're telling the calculator to do on this one is square a 7 and multiply by a negative 1. It's doing order of operations. Uh-huh. Mm-hmm. That's why I go ahead and just square it and write whatever it is squared right there, because then it's not an issue, ever. Okay? So, let's go ahead and finish this real quick. What is 4 times 2 times 3? Or 4 times 3 times 2. Remember, it doesn't matter what order we multiply. Thank you. Just right there. 24. So I have x equals negative 7 plus or minus the square root of 49 minus 24 over 6. Right? What is 49 minus 24? Negative 7 plus or minus the square root of 25 over 6. I know the square root of 25, do you? I know you do. What is it? Y equals negative 7 plus or minus 5 over 6. What is negative 7 plus 5? Negative 2. What's negative 2 divided by 6? It's a fraction, isn't it? Negative 1/3. Negative 2/6 is the fraction. We simplify it. What did I do? Oh, I don't know. Thank you for catching that. Sorry about that. I guess I'm just so used to saying y equals everything. We're still on x. We're still on x. Sorry about that. So what's negative 7 minus 5? Negative 12 divided by 6? Negative 2. Do you see how exciting the quadratic formula can be? Okay, what this table up here is about part of the quadratic formula. A very special part, b squared minus 4ac. Where is that? Do you see it in the formula anywhere? It's under the radical, under the square root sign, right? But all we're talking about is b squared minus 4ac. The discriminant, guys, that doesn't mean somebody has to sit in the back of the bus. That's something completely different. Okay? The discriminant can tell us information about the solutions before we actually answer them. Okay? So on this problem that we just did, if we did the discriminant, because see, it even says find the discriminant and use it to describe the nature of the roots of the equation. Okay? When we did the discriminant, we got 25, didn't we? 25, is that equal to 0? Is it greater than 0? Is it a perfect square? Yes. If so, we're going to have 2 rational roots. Guess what we got? 2 rational roots. So the discriminant was 25, and we get 2 rational roots. A kind of number, a rational versus irrational. Irrational numbers. Do you remember that foldable we made at the beginning of the year? It should be in your notes section. Okay. We may need to go back and recreate it for you if you can't find it, because it's kind of important right now when we're wanting to talk about real numbers versus imaginary, rational versus irrational, things like that. Okay? An irrational number is a number that cannot be written as a fraction. Okay? Okay, so any questions about A? All right, look at B. Let's write it in standard form first. Let's get it equal to 0. So what do you want to do first? Very good. Subtract 2x from both sides. Add 2 to both sides. So I get x squared minus 4x plus 2 equals 0. Yes, sir? What's A? A is 1. What's B? Negative 4. And what's C? 2. X equals negative B. Did you see what happened right here? Because it was already a negative 4, so when I do negative B, it's already just a 4. Plus or minus the square root of B squared minus 4AC all over 2A. Oh, I even said we were going to find the discriminant, and I totally even forgot. Let's find the discriminant real fast before we go on, okay? B squared minus 4AC is the discriminant. B squared is 16 minus 4 times 1 times 2. 4 times 1 times 2 is what? 8. So 16 minus 8 is what? 8. Is it equal to 0? Is it greater than 0? But is it a perfect square? Okay, is it greater than 0 and not a square? So we're going to end up with 2 irrational roots. Okay? So 8 is the number, 2 irrational roots. Now the good part about finding the discriminant first is what do we already know? What number goes under the radical? 8. Do you know the square root of 8? Hey, me neither. But what do I know about 8? Isn't 8 really the same as 4 times 2? And don't I know the root of 2? I mean 4? Sorry about that. So what is the root of 4? 2 root 2, because that's what's left, right? Over 2. Now, in the numerator, can I get inside and mess with this too? No. So I have a 2 plus or minus 1 root 2, right? I factored out a 2 from each of these two terms, the real term and the imaginary term, divided by 2. What happens to these two? They simplify to 1, don't they? So what am I left with as my answer? X equals 2 plus or minus root 2. You can put the 1 on the outside if you want. That's one of those places the 1 is not necessary. Yes, sir. No, absolutely, you can write these together. You don't have to write 2 plus root 2 and 2 minus root 2. That's why we were talking about the conjugates earlier, so that you remember. I know the plus or minus is in the formula, but this is another way to think about it, because you're actually getting 2 solutions. Does everybody see that we're getting 2 solutions? One of the solutions is 2 plus root 2. One of the solutions is 2 minus root 2. You okay with that? Okay. I think we have time for one more. Okay. So, let's get it equal to 0. We got to do that first. So, subtract 14x from both sides and add 58 to both sides, right? So I get x squared minus 14x plus 58 equals 0. I'm going to draw myself a line here so I don't get messed up. Let's find the discriminant. Okay? B squared minus 4ac. B squared is 14 squared. Do you know what, sorry, negative 14 squared. Do you know what 14 squared is? I had to look it up. I couldn't remember off the top of my head. It's 196. Minus 4 times 1 times 58. Right? What's that equal? It should equal negative 36. Okay. What does that tell us? Is the discriminant greater than or equal to 0? Is it greater than 0? Is negative 36 greater than 0? No, so that skips both of these. Is it less than 0? So I'm going to get 2 complex roots. 2 complex roots, which means my answer is going to have to do something with I. Okay? So I already know my A is 1, my B is negative 14, and my C is 58. X equals negative B plus or minus the square root. Ooh, I can just go right here, can't I? B squared minus 4AC, because I already found that right here. All over 2A. X equals 14 plus or minus what? 6I over 2. Anybody notice anything? Okay, so if I factor out a 2 from the numerator, I'm left with 7 plus or minus 3I. Right? And what can happen to the 2's? They simplify to 1, right? So my answer is just x equals 7 plus or minus 3I. Got it? Any questions? Okay. 1 through 10 on the back. Keep in mind that I will not be here tomorrow, so I will check 1 through 10 on Monday. You will have a worksheet solving quadratic equations by the quadratic formula tomorrow. Okay, so don't just think I'll just wait till Sunday, because that will give you more than you could probably handle in one day. So work on these tonight. You will have some time in class tomorrow, but you will have another worksheet tomorrow as well. Okay, do you have any questions about this? All right, have a great day.